Okay, let's kick things off. Today's deep dive is really getting into the bedrock of what we see now with AI. We're talking about the origins and evolution of LLMs and generative AI. I'm honestly quite excited to, trace that path, see how we got from point A to, to here.
It's definitely a crucial topic, and the source material we have actually points this out pretty clearly. Sources 1 and 3 specifically frame this historical look as like the necessary next step after getting the basics of today's AI applications down.
Ah, okay.
Yeah, they kind of lay out a map, a high-level view of this history. It's based on general knowledge, they mentioned, even while saying the really deep specifics aren't detailed in these particular documents.
Gotcha. So the sources hand us the topic, say this is important history, and give us a kind of roadmap. We're using their overview to guide us through how things evolved.
Exactly that. The sources set the destination, understanding the backstory of LLMs and generative AI. And based on their overview, that story starts way before we even had terms like LLM.
Right. The summary points back to the mid-20th century. Early language processing attempts. What did that actually look like back then?
Well, those first tries, the source notes, were mostly rule-based.
Rule-based.
Yeah, think really rigid systems. Programmers trying to hand code specific grammar rules, linguistic rules, but they were brittle, They just couldn't cope with how messy and varied real human language is.
So you'd need a new rule for every single exception. That sounds painful.
It was, and the source definitely highlights that weakness. Eventually, that led people to shift towards statistical methods.
Okay.
So instead of hard-coded rules, systems started looking at patterns, frequencies in huge amounts of text, like how often words pop up together, common sentence structures, that kind of thing.
Moving from writing the rules down to just observing the patterns in the wild, The sources say this was better, but still had pretty big drawbacks, right?
Yes, exactly. Performance got better on some tasks, sure, but they still didn't really understand meaning or context, not deeply. They could analyze text based on probability, like what word is likely next, but they couldn't truly, read or generate complex, coherent stuff like we can.
Okay. And the overview in the source material suggests this is where machine learning starts becoming a bigger player in NLP, natural language processing.
Correct. As we got more computing power, and crucially more data, standard machine learning techniques started getting applied to language. Things like support vector machines, hidden Markov models, basically more sophisticated tools for recognizing patterns. These models could actually learn from data, which was a big step up from just counting stats.
But still, we're not talking about generating fluent text or having proper conversations yet. The source seems to then jump ahead quite a bit to the return of neural networks.
That's highlighted as a really critical moment in the summary, yeah. Neural networks weren't new. They'd been around for ages, but what the source calls the deep learning revolution around the early 2010s, that just changed everything.
How so?
Well, you had massive data sets becoming available, much more powerful hardware GPUs especially, and new algorithmic tricks. Suddenly, deep learning models became incredibly good.
And how did deep learning specifically shake up NLP?
The source indicates that these deep learning models, specifically types like RNNs, recurrent neural networks, and even CNNs, convolutional neural networks, were just much, much better at handling sequential stuff, like text. They could learn way more complex patterns, relationships between words across sentences, paragraphs even. This led to huge jumps in things like machine translation and speech recognition.
Okay, now we're getting closer to the modern era. And the source overview points to one specific architectural breakthrough as the key moment, the real pivot point.
Yes, absolutely. The source really emphasizes the introduction of the transformer architecture. This was a massive shift.
Yeah.
It moved away from processing text word by word in sequence like RNNs did. The absolute key innovation, as highlighted, was this thing called the attention mechanism.
The attention is all you need paper. The source mentions that one. What did attention actually let the models do?
So the overview explains that attention allowed the model to weigh the importance of all the words in the input text when processing any single word. Crucially, it didn't matter how far apart the words were.
Okay, so not just looking at the immediately surrounding word.
Exactly. Think of it like you're reading a long document and you can instantly glance back and forth, highlighting the most relevant bits for the sentence you're currently working on instead of reading strictly word by word and trying to remember everything.
Right, so it gets the bigger picture. It can see those long-range connections much better. And the source says this became the foundation for pretty much all modern LLMs.
That's it. Once the transformer gave them this powerful way to process language, the next big phase, according to the source's description, was just scaling up.
Making them bigger. That's where the large language model comes from.
Precisely. The source points out that researchers basically discovered that if you dramatically increased the size of these transformer models, like giving them billions, even trillions of parameters.
Parameters being the values they learn.
Yeah, the things they adjust during training. So make them huge and train them on absolutely vast, unprecedented amounts of text data. Doing that just unlocked totally unexpected abilities. The source explicitly links this scaling success to having those massive data sets and the raw computing power available.
And these giant models, they started doing things they weren't specifically trained for. Like you said, having conversations, writing code, poems.
That's right. The source notes these scaled-up models showed these amazing emergent abilities. Things like really deep understanding of context, generating text that was super coherent, creative even, and doing tasks like translation or summarizing or answering questions with hardly any specific examples, what they call few-shot or zero-shot learning.
And that ability, the generation part, that's where the link to generative AI really clicks into place based on the source's summary.
Yes. The source explains that as these LLMs got so good at creating really high-quality text from prompts, they became the prime examples of this broader category we now call generative AI. You know, AI systems that can produce new content, text, images, code, music, whatever, based on the patterns they learned from all that training data.
Wow. Okay, so walking through that path, sketched out by the sources.
Right.
We went from clunky rules to statistical patterns. Then applying machine learning, then the deep learning boost for sequential data.
Right.
Then the huge leap with the transformer and its attention mechanism.
A key breakthrough.
And finally, just scaling everything up, models and data, to unlock these almost surprising generative abilities we see today.
That's the progression, yes. From those very early limited systems to the huge, powerful generative models now. That's the historical story the source's overview presents as the road to modern LLMs and generative AI.
So reflecting on this, what we've really learned from the sources we looked at today is that this topic, the origins and evolution of LLMs and generative AI, is clearly marked as the next big thing to understand after the foundations.
Exactly. The sources basically give us this crucial roadmap. They lay out the key stages, the ones we've just talked through, based on their sort of general knowledge summary. But importantly, they also state pretty directly that the really detailed history, the nuances, the specific papers and breakthroughs, well, you need to go look at other resources for that. It's not all contained in this material.
Yeah, it's like getting a really detailed table of contents for an amazing book. It tells you exactly what chapters you need to read, what ground you need to cover to get the whole story, even if the book itself isn't fully included right there.
Right. And that brings up, I think, an interesting point for you, the listener, to maybe consider in your own learning. What do you do when your starting point, your source material, tells you, hey, this topic over here is really important, and it even gives you the basic outline, but doesn't fill in all the details? How do you take that outline and use it as a guide to, bridge that gap, to go find the extra pieces you need to build that really complete picture for yourself? It's sort of a question about piecing knowledge together, isn't it?